No problems out here, but these are to be understood from the perspective of any conceptual question. First of all comes circular motion. Very short topic, and we will also discuss it in a short manner. Okay. Circular motion. Now this is more about discussion. A circular motion is a motion which is taken by a body that moves along a circular path. So we need to have a circular path. And obviously, since it's the case of motion, so you also need to have a body, right? So you have a body and the body is moving in a circular path. So whenever you're moving in a circular path, you will be having something which is known as the radius of the path. Okay? So the motion that we had studied in chapter 1, that was all about motion, straight line motion, right? Uniformly accelerated motion in straight line. Now circular motion we studied in depth in grade 11. We introduced in grade 9 for you to understand facets related to acceleration, forces applicable, velocity, as well as displacement. Okay? So if you look at the displacement, displacement is all along the circumference. Is this clear? Displacement is all. So if you actually move one round, say suppose if you move one complete round, then what will be your displacement equal to? Yes, your displacement will be equal to 0. What will be your distance equal to? 2 pi r. How many of you have understood this? Displacement is the shortest straight line distance between 2 points, right? If you actually move half a round, then can you tell me what is your displacement? Displacement will be 2r. Displacement is shortest straight line distance between initial and final. Your distance would be pi r. Oh, clear? Understood? Right. Now, then we talk about our next parameter out here. So this is you have understood about displacement and this thing. Let's talk about the speed. Let's talk about the speed. The speed is always given as distance upon time. Distance upon time, and the speed is a scalar quantity. That means it has only magnitude. It has only magnitude and it does not have any direction. So will you be able to compute the speed of a body undergoing a circular motion? Obviously, you just need to know how much portion of the circumference it has moved. Let's say if we consider a motion from here to here, then the distance is how much? Pi r is the distance. Did you understand what is pi r? 2 pi r is the complete circumference. So if you are moving only half a circle, what is your displacement? Pi r should be your displacement. Pi r divided by t. समझ में आया? Clear है? This is how we actually try to find out our displacement. Sorry, our speed. Interesting part comes is when it comes to velocity. Now in circular motion, velocity is where you will be asked questions about velocity. Velocity is a vector quantity. Vector quantity. That means it will have both magnitude as well as a direction. Is this thing understood or not? It will have a magnitude and direction. Okay? Now let's imagine a case where, let's imagine that our assumption in this case is that body moves in constant speed. That means the value of speed is constant. Understood? Speed constant speed, like it's moving constant. The way a DVD disc, you have seen DVD disc move, or the hands of a clock are moving, it's moving in constant speed, right? A question arises, what about the velocity? And let's say this constant speed is something called v. This is the constant speed is v. So our body is moving with a constant speed. and let's say the constant speed is v. Question arises, sir, what about the velocity? Because velocity is a vector quantity, you are supposed to have magnitude as well as direction. So the magnitude portion can be easily addressed. We'll say that the magnitude is equal to v, because what is the magnitude of velocity? The magnitude of velocity is always the speed. Is this understood? Magnitude of velocity is always the speed. What is velocity? Velocity is speed in a particular direction. As long as we were discussing about speed, direction was not our headache. But now we are talking about velocity. So this particular body is moving in a constant speed, and I now want to understand what is its velocity. So let me give a position of this body. Let this position of the body be A, and then I take the body, and body has covered some bit of circumference, and the body has now come here, and let this position be known as B. Okay, now question is, what is the velocity at A and what is the velocity at B? So we will denote it like this. We are interested to find out velocity at A, and we are interested to find out velocity at B. If you look at A, then you should also give what is the magnitude at A and what is the direction at A. Here also you should give what is the magnitude at B and what is the direction. Now the magnitude in both the cases will all be the same, and this will be equal to the speed, which is equal to v. Have you understood this part or not? ये समझ में आया? Because the body is moving with a constant speed, therefore its magnitude at any position will be same, but the direction changes. How do you find the direction? The direction is such, the direction will be such that the direction of velocity will always make a tangent with, with the point of contact out here. You know what is a tangent? A tangent is a line. You know what is a tangent? No to no, don't worry. If you don't know, okay. बोला करो. ठीक है? Tangent किसको बोलते हैं? A tangent is a line that touches a circle exactly at one point. This is a circle. This is called a tangent. This is known as a tangent. And the point where the circle touches the tangent, this particular point, this is known as point of contact. Point of contact. Okay? This is known as point of contact. A line which actually cuts the circle in 2 points, such a line is known as a secant. S-E-C-A-N-T. This is known as a tangent. And keep it in your memory that the radius at the point of contact is always perpendicular with the tangent. A radius at the point of contact will always be perpendicular to the tangent. Jahan tangent draw karoge, wahan pe radius will always be perpendicular. So when we talk about when we talk about circular motion, a circular motion will have displacement, a circular motion will have distance, but what gets interesting is, what about the velocity and speed? So for this, to understand this, we took a scenario where the body is moving with constant speed. So with that analysis, we are trying to find out what are the velocities at two different places. So the velocity here will be given as a vector VA. Now this is a vector. Vector means though the magnitude is V, the direction now is completely different. यहाँ पे देखें तो कैसे देखेंगे? देखो. Here the velocity will be VB as a vector. And the most interesting thing in circular motion is VA as a vector will never be equal to VB as a vector. However, if you try to look at their magnitudes, VA as a vector, its magnitude will always be equal to VB. कोई भी चीज समझ में नहीं आया तो पूछिए, don't gulp it. The magnitudes will always be same because our assumption is what? That the speed is constant. Mixer grinder. A mixer grinder, we have a mixer grinder which runs at 1200 RPM. Do you know what is RPM? Revolutions per minute. Okay, लिख लीजिए. Problems आएगा तो ऐसे आएगा. RPM. RPM stands for revolutions per minute. So I have a mixer grinder whose RPM is 600 RPM. जैसे ही आप on कर दोगे, the mixer grinder is running, means it is making 600 RPM. That means constant speed. Agreed? But the velocity is not constant. Velocity depends upon at what position you are analyzing the velocity. Magnitude of velocities will be same. ऐसे केस के मोशन को हम क्या बोलते हैं? यूनिफॉर्म सर्कुलर मोशन. Sir, what is it different from the uniform linear motion that we studied? In uniform linear motion, body's velocity is uniform. Just try to think, what is uniform motion? A body is said to be in uniform motion if it covers equal distances in equal intervals of time, no matter how small the time intervals are. In 1 hour, if you are going 60 kilometers, in 1 minute you should go 6 kilometers. That is uniform motion. Half a minute you should go 3 kilometers. There the velocity is constant because you are going in a straight line. In uniform circular motion, it is constant speed but not constant velocity. ये true or false आ जाता है. So if it is not constant velocity, something that your heart will now find very difficult to absorb. Although I have got the word uniform out here, I will write uniform circular motion, which is UCM. I will write UCM is a accelerated motion. Very, very dicey statement, but very true statement. Uniform linear motion is non-accelerated motion. Try to think. Uniform motion means velocity is constant. Acceleration doesn't take birth at all. That is in the case of linear, what you studied so far. Now what are you studying? Circular motion. Uniform circular motion is a accelerated motion. You remember when we were studying about the Rutherford could not explain the stability of an atom. Well, did we discuss about it? Yeah. So what did we say? Rutherford said that the electron moves in circular orbit. So if the electron is moving in circular orbit, it is an accelerated motion. Uniform circular motion is accelerated motion. And if a charged particle is moving as in an accelerated motion, the charged particle should emit wave. It should lose energy. And if it loses energy, it should come and collide with the center. That did not happen. That was the drawback, that Rutherford could not explain the stability of atom. तभी बोला था आपको. Always write down uniform circular motion is an accelerated motion. However, the speed is constant, but the velocity is not constant. And if you want to talk only in terms of velocity, we'll say the magnitude of the velocity is constant. The speed is not constant. Sorry, the direction is not constant. Clear? Understood this much? Right? Now try and think about uniform circular motion. We try to make some observations for uniform circular motion. So we have a naughty child out here. What the child does, the child ties a thread and a particular stone on it and starts moving it in this manner and keeps the speed constant. Uniform circular motion? Yes, uniform circular motion. How is the body moving? Sir, the body is moving in a circle whose radius is actually the length of the string that is attached, and my hand is supposed to be the center. A body घूम रहा है. मतलब अगर एक बॉडी को यूनिफॉर्म सर्कुलर मोशन में रहना है और से एनी सर्कुलर मोशन में रहना है, the body has to follow what? Circular path. If the body has to follow a circular path, there will always be a force which will be acting towards the center like this, which will be actually keeping the body in a circular path. This force acts like this. Look at here, children. The geometry that I told you, radius at the tangent is always perpendicular. That means this particular force will always be perpendicular to the velocity vector. Are you understanding? थोड़ा सा मुश्किल हो रहा है. Don't make. I can make with your faces. Now try understand. Girls, nowadays you all are modern girls, so you all might have not played. But if you go to a rural or semi-urban or rural places, girls have got a game where they hold hands together और घूमते रहते हैं. At that time, say Nidhi and you are playing, and this is the mischievous girl. She just loosens her hand. What happens? You flung open and you will just fall down. That means every time that you turn, there is a force which is keeping you inward. Otherwise, the body always wants to go to the outside direction. ये body को सोचो. Why does your mom tell you don't do that? लग जाएगा, क्योंकि फटने से छटाक करके जाएगा. And how will the body fly? मान लो यहाँ पे तुम काट देते हो स्ट्रिंग को, ये टेंजेंशियली फ्लाई करेगा. So imagine you are on a merry-go-round and the merry-go-round is going at a high speed, and suddenly, Pattu, you will not go in round, you will go tangentially from the point. Have you seen discus throw? As a discus throw, discus, not javelin, discus. So in discus throw, the athlete will do first ऐसे post करता रहेगा, ऐसे ऐसे करके, and then he will twirl on his toe, ऐसे घूम के जाके then discus को ऐसे मारता है. That is a radial throw, tangentially, and then the discus flies away. Hammer throw. समझ में आया? Or say in Ramayana, if you have seen Hanuman tying all those people to his tail and ऐसे घुमा 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 ऐसे फेंकता है ना, तो आदमी छिटक के जाके गिरता है. So uniform, in order to have a circular motion, there has to be a force which is always directed radially inwards towards the center. चलिए लिख लें इसको, that for circular motion, okay, we were talking about circular motion, you need a force, and that force should be radially inwards, to keep the body in its path, and this force is known as centripetal force. Centripetal force. This force is known as centripetal force. Centripetal force is the force which acts on a body which is performing a circular motion, and the force is always directed radially towards the center. Now your next question to me should be, what is the formula of centripetal force? I will say there is no formula of centripetal force. Why? अलग-अलग केस में अलग-अलग forces centripetal force का रूप धारण करता है. What did I try to say? Sir, do you have a formula for this centripetal force? Means centripetal force is this one, beta, FC. FC. It is a force which is towards the center and which keeps you in the center. Like if we play that girl game, then we are holding. I am pulling you inside the center, you are pulling me towards the center, and we are making a round. Imagine the thread with which you are trying to do this. If you make the thread slack, तो घूमेगा सर्कल में? नहीं घूमेगा. So centripetal force का कोई formula नहीं है. What I said, in different scenarios, different forces will take the role of centripetal force. In the case of that naughty boy whirling a stone with the string, the tension of the string is the centripetal force. In the case of Rutherford, the electron and the nucleus, electrostatic force of attraction is the centripetal force. In the case of Earth and the Moon, gravitational force is the centripetal force. In the case of Dhruv, driving his car, जैसे drive करता है, friction of the tire is the centripetal force. Friction is trying to keep you inside. On the orbit, आप साइकिल चलाए हो, speed turn लेते हो. All of you who have done bike riding or cycling, say this is the track, right? If you come slow, nothing stops you from taking the innermost edge and then cycling. If you come fast, कभी-कभी आपको इतना पास आने में डर लगना शुरू हो जाता है ना? You don't get the confidence. You try to negotiate a larger radius turn. That's why that is friction. Friction is a limiting force. To some extent, the friction will be holding you inside. If you disobey friction, then आप गाड़ी जब skid करता है, देखियो कैसे गिरता है, छिटक के जाके गिरेगा हमेशा. All these races and what happens. So the centripetal force is given by friction. In case of atom, nucleus and the electrons, centripetal force is given by nuclear force of attraction. In case of heavenly bodies moving around the sun, the nuclear force is given by, the centripetal force is given by the gravitational force. Tension, you know, right? Tension आपको पता है? What is tension? Look here. Let's say I have a suspension system like this, and I have hung a stone out here. The stone will have its weight exerted downwards. Still the stone is not falling down. That means the thread is holding it tight. Some force must be working in the opposite direction. This is called the tension. Once you have beaten the tension, that means the thread will snip off and it falls down. In order to understand tension in very complex diagram, the best way is, where do you want to understand tension? At the ball, right here. Sit here and open an umbrella. Whichever direction the umbrella opens, tension is in that direction. That's the easiest way to understand tension. समझ में आया? ठीक है? So is centripetal force understood by you? Centripetal force का direct कोई formula नहीं होता है. So there may be a scenario based question where they say a boy is whirling. What is the centripetal force? The tension is the centripetal force. What are the takeaways from the discussion we had so far? The takeaways are, what is circular motion? A motion in which a body moves along a circular path is called circular motion. This fan, right? If you look at this fan, then if you place a small, say, magnetic sticker on this particular blade of the fan, then the magnetic sticker is making what motion, beta? Circular motion. And right the tip of the fan at the center, what motion is that? Rotational motion. Look at the marker pen. Look at the marker pen and look at me. Look at the marker pen and look at me. The marker pen is undergoing circular motion. And this point on my head is undergoing rotational motion. It's just pivoted at the same point. Position change नहीं होता है. Rotational motion is always on the axis of rotation. Circular motion is on the hand. हम circular motion पढ़ रहे हैं. Circular motion में एक body की speed को अगर हमने constant कर दिया, ऐसे motion को हम कहते हैं uniform circular motion, also said as UCM. What is the speciality about UCM? In UCM, speed is constant, velocity is not constant. Why? Velocity's magnitude is constant, direction is different. How is the direction different? Whichever point you want to measure the direction, draw a tangent to that particular point. एक point पे एक ही tangent होता है, दो tangent नहीं होता है. यहाँ पे आप बोलोगे सर tangent ऐसा भी हो. Tangent is a line which touches the circle at one point, and at one point we can have only one tangent. The tangent gives you the direction of the velocity. So obviously when my body is here, the tangent is in this way, and this, the tangent is in this way. So the directions differ, though the speed is same. Now if the velocities are not equal, whenever velocity is not equal, who is born? Acceleration is born. Therefore uniform circular motion is known as a accelerated motion. And in uniform circular motion, how does it become possible for the body to remain in a circular path? There is an inward force which keeps the body in a circular path. That inward force which is directed radially inwards is known as centripetal force. Take a bucket of dal and start rotating the bucket with full speed. Not a single piece of dal will spill out. Centripetal force. Dal अंदर की तरफ, dal बाहर नहीं गिरेगा, कुछ भी नहीं गिरेगा. There is centripetal, there is centrifugal. Fugal we'll study later, that's not in your course, that's not complex. And question arises, is there a formula for centripetal force? Well, we can't have a direct formula because different forces play the part of centripetal force based on what is the scenario. An electron rotating around a nucleus, nuclear force of attraction is performing the role of centripetal force. A stone tied to a thread, tension is performing. A person taking a steep turn on a road, friction of the tire is giving you the centripetal force. Earth moving around the sun, gravitational force is giving the centripetal force. And that's how you will be in that particular thing. Clear? If there is any question, you can ask. I have not seen any sort of problems on this basis. Okay, which now makes us move to the next section, which is known as friction. Is it friction now? Yeah, we have friction now. Small topic, again a discussion topic. Can I rub this? Okay, right, very good. Our next topic is friction. If we go by English way, friction is a phenomenon. And what is this speciality of this phenomenon? His job is to oppose motion. So if you want to give motion, friction will always oppose motion. That phenomenon is known as friction. And you're trying to oppose motion. Now, in chapter 1, we only studied facets of motion like velocity, acceleration, initial, final, displacement. Now, when you talk about motion from our next chapter, that is laws of motion and the reason for motion, in order for motion to happen, a force must be acting on you. Otherwise, how are you having motion, right? There is a force acting on you. And if you are trying to oppose motion, then you are also giving another force, which is opposing the direction of motion. Yes or no? Right. So this phenomenon gives birth to somebody who is known as the frictional force. Frictional force. And the frictional force is always, force is a vector, directed opposite to direction of motion. Directed opposite to direction of motion. ठीक है, समझ में आया? And we will also see a literature part of it also. Exactly, English literature, उसमें भी मजा कर देंगे आपको, ठीक है? So we say suppose, now let's say this is a surface. This is a surface or a tabletop, you can say, on which I have kept a body. I have kept a body. Now, in order for friction to happen, there always has to be a contact between the two surfaces. There has to be a contact, physical contact, right? So this particular portion, I will say, is the interface. Or here we have the contact between two surfaces. Two surfaces. One of the surfaces coming from the body and one of the surfaces coming from the tabletop. And this is a mandatory criteria. Mandatory. ये होना ही पड़ेगा, वरना friction नहीं होगा. This is a mandatory criteria. Understood? Okay. Now we said friction is a phenomenon due to which it opposes motion. Now what do? We start to push this, okay? Or say we start exerting a force in this direction. So we start giving it a force, and let's call this as F pull. We start giving it a force, which is called F pull. Such a nice diagram, and you make one diagram with hand and it becomes so bad. Okay. So this is F pull. But it is interesting. Now try to understand, children. We'll not try to give F pull right at once. I also know that this is a small eraser on this particular table and the eraser can be pushed. Don't think yourself like a human being with having big fingers and all. Think that you're a hamster. What are you? You're a hamster, cute little hamster, and you've got small little legs out there and you're trying to push it. Initially, you will see that the same scale of the ruler or a duster or say the water bottle of Dhruv or her phone which is on the table, which you and me can just push it. The hamster is unable to push that. Maybe not possible. So we're going to do like that. And what we do, we start pushing it slowly. Initially, we see that if we push it very slowly, this body is unable to move. Why is it not moving? Am I being someone who is not exerting force? No, sir, you are exerting force. Then why is it not moving? There is a frictional force which is also acting. There is a frictional force which is also acting. And the frictional force will always act along the contact between two surfaces, but it is acting opposite to the direction of motion. Okay, participate now. It is acting opposite to the direction of motion. तो मैं क्या करता हूं? मैं थोड़ा और यहाँ पे ताकत बढ़ाता हूं, slowly, gradually. फिर भी सर नहीं मूव हो रहा है. थोड़ा और बढ़ाओ. जैसे ही थोड़ा और बढ़ाया, सर मूव हो गया बॉडी. Why did the body move? Why did the body move? The force is greater. Very good. You have overcome friction. Think very simple. You have overcome friction. The body does not move till now. We don't know whether friction was equal to the pull or something. We don't know. We know one thing. We know one thing, that in order to move something, right? Say, if this is the effort ladder, then in this effort ladder, let's use this later. If this is the effort ladder, then there will be something based on the contact surface and body. Now this is very specific. This is not for everyone. This is for a particular system. There will be something called the force of friction. This is pre-established. This depends on body, the weight of the body, the surface area of the body, right? And the roughness of the surface. Based on that, there will be a friction force. If you cannot overcome the friction force, body will not move. Body will move only when we have overcome friction, right? And when you overcome friction, at that time, let our friend Kirtan be pulling the body now from here. He has applied a force which is equal to F pull. So what is the net force that is acting on the body? The net force will be F pull minus F friction. This is the net force. Yeah. Depends on the body means, सोचो तुम नीचे सो जाओ, कीर्तन को सुला दो नीचे फ्लोर में और मुझे सुला दो और बोलो दोनों को ड्रैग करो. Will we offer the same friction? You will be, yeah, 1 minute, 1 minute बिट्टू. We will be able to overcome Kirtan's friction quickly. He's light ना, उसका mass कम है. हाँ, that depends on the geometry of the body, properties of the body. That will come later. Right now, why I'm saying that? Because I'm saying that there is a bar. This bar is not same for everybody. For every body and its contact surface, there will be a bar which will be established. This bar depends upon the body's weight, the surface area. Now imagine I am sitting on the floor with just one hand. Suppose I'm in the air with one hand. Only this much portion is in contact. It is easy to move me. But अगर मेरे जैसा ये बल्कि बॉडी ऐसे से सो जाए बकासुर की तरह, तो मुझे मूव कर पाओगे इतनी जल्दी? नहीं ना. तो सरफेस एरिया भी डिपेंड करता है. Got it? So आपको अगर बॉडी को मूव करना है, if you want to move the body, you have to apply a force which is more than the friction, right? In this scenario, the net force acting on the body will be F pull minus F friction, net force. And if you try to apply Newton's first law, then this net force should be now equal to the mass of the body multiplied. Force means there will be an acceleration which is coming on the body, will be equal to mass into acceleration. ऐसे problems आएगा तो ऐसे सोचा करो. Did you understand? The net force now should be equal to the mass of the body into the acceleration that will be created in the body. Obviously, whenever there is a force, there has to be an acceleration. Don't you agree? That acceleration is not, suppose I tell you that there is a frictional force of blah blah Newton, and Kirtan is about to move it by giving F pull which is equal to some tla Newton. Mass of the body is so and so. Calculate acceleration. What do? You just divide this force by the mass. Zero हो जाएगा आपका. Net force. A body at rest remains at rest unless and until it is acted upon by an external force. This is external force, this is internal force. So we have to look for the net force. The net force is this. This net force is equal to the mass into acceleration. That will be causing the acceleration. Not just Kirtan's pull. Kirtan's pull is getting nullified to some extent by the friction. As long as the body remains to be in contact on that surface, friction is always there. But you have overcome friction. This makes us conclude one more thing, that when you talk about this frictional force, it is a limiting force. Sir, what do you understand by the word limiting force? That means there is a maximum value, it has a limit. इसके बाद अगर आपने उस फोर्स को ओवरकम कर लिया, आप मूव कर सकोगे. Ashmita, I'm coming back to you. Just hold on. Okay, let's go to crowded market where a lot of cargo movements happen. Typical Desi. Okay, now look at me. There will be big boxes, and that person box को जब move कराता है ना, वो move करते ही बहुत friction है. Then once it starts moving, he has overcome friction. And then if you are standing in front of me, side ho jaye, side ho jaye. He doesn't want to stop, because every time he stops, he has to again exert the force right from the start. और फिर उसको फ्रिक्शन ओवरकम करना होगा. बात समझ में आ रहा है आपको? एक बार फ्रिक्शन डिफीट हो गया ना, that's what we call friction is a limiting. Means when he is moving the body also, friction is still in there. It's not that it's disappeared, it's still there. But your net force has now overcome friction. समझ में आ गया? जैसे ही आप रुक गए ना, they feel very irritated. You will see people who are pushing stones. Suppose you are pushing a box and your little one in front of your house is dancing in front of you. Don't you feel irritated? You will feel irritated, because once it stops, you have to push it again. So friction is a limiting force. अब आएंगे types of friction में. Yes, Ashmita, let me take your question and then go ahead. Yeah, बेटू बोलो. No, it will act on body in motion also. It's friction is acting. I told you, friction acts as long as there is mating between the two surface. If there is mating between two surface, friction होएगा ही होएगा. Sir, I am Hanuman and there is no sort of surface contact with me. So what? Air is there. Air के साथ तो आपका contact हो रहा है ना? Drag. उसको हम बाद में पढ़ते हैं. That is friction due to fluids. That is known as drag. Make a thick strawberry milkshake and put a cherry. The cherry doesn't drown immediately. धीरे धीरे जाएगा. Why? Drag. We studied about drag when we were studying terminal velocity. So ये जो friction word सुनते ही आपके दिमाग में आना चाहिए solid in contact with solid. Solid in contact with solid. As long as it is stationary, you don't get to know what is friction. So can you tell me how to measure friction? Well, we don't know how to measure friction. The best way to measure it is put a spring balance out here, right? And tie it to a spring balance, put a pulley out here and put a pan out here. How will we try to do it? इसका friction measure करना है. इसका friction measure करने के लिए यहाँ पे एक pulley लगा दिया and we have put a pan out here, right? A pan out here like this. And we put a spring balance out here. And keep on putting weights. As you put on weight, the spring balance will indicate the extension. You'll get the extension. And as soon as you get the extension, you can find out the spring balance will give you the reading. At a particular reading, the block just begins to move. Just begins to move. That is friction. That is the value of friction. Okay, let's put it some other way. I want to understand how much strength does Kirtan have in his fist. We don't know. So what we do, we make Kirtan do an arm wrestling with a robot. And slowly what we do, we see Kirtan is winning. So we increase the robot's stiffness. After a particular point, we will see that both of them have locked on. Because now the robot is also applying power. Then we will increase it a little bit more and we'll see Kirtan just getting defeated. The point at which Kirtan is just getting defeated is Kirtan's strength. Yes or no? That's the way to get it. Is your strength. So how do you understand what is the friction out here? The force, the pulling force at which the body just begins to move is called the friction. Now, उसका एक particular नाम देना होगा, क्योंकि ये body कैसा कर रहा है बेटा? Slide कर रहा है. ऐसे motion को हम क्या बोलेंगे? Sliding motion. This is again a new pen. No, I want to use it. Okay. We'll call it sliding motion. This is sliding motion. So the friction is known as sliding friction. So if somebody says, how do you get to know the sliding frictional force of this body? The sliding frictional force offered by this body is the force at which can be measured by applying an external force at which the body just begins to slide. Oh, sorry. Sliding se pehle, ek minute, before going to sliding, one thing. Let's say the body is right now at rest. Very sorry. The body is at rest. So here the friction that the body offers, we will call it not sliding, we'll call it as static friction. Static friction. Static friction is the friction which comes into play till the body is in rest. Till the body is in rest. Understand very carefully what I'm trying to say. When the body is at rest, the friction that the body offers is known as static friction. Sir, how long does static friction work? Till you don't succumb to the external force and begin to move. Have you understood? As soon as you begin to move, sir, what happened? Where did the friction go? The friction still continues, but now since you are sliding over another surface, I will say that your static friction has now changed to sliding friction. ये चीज समझो बेटा. Please understand the difference between this static, sliding. Friction वही है. Friction. Friction can be a static friction, can be a sliding friction. For static friction, what is the necessary condition? Body is at rest. For sliding, body is in motion. When does static convert to sliding? When does static convert to sliding? When the body just begins to slide. When it just begins to slide, till that the resistance you are going to offer is known as static friction. You cannot measure static friction in motion when you just begin to slide. After that, as you are sliding, the friction offered is known as sliding friction. So my question to you, which friction is more, static or sliding? Static is more. Sliding is less. Imagine that porter on the box. Porter is very happily takes it. Friction is something which opposes me. मतलब फ्रिक्शन आने से मेरा मुंह ऐसा हो जाना चाहिए, है कि नहीं? मुझे ओपोज करता है ना. अब you have kept a big box on the floor. Box is stationary, static friction. How will we move it? Look at me. We'll do like this. जोर लगाओ, जोर लगाओ, जोर लगाओ. Sir, friction is still defeating us. और जोर लगाओ. जैसे ही जोर लगाया, we defeated what friction? Static friction. Now body is in motion. Now we are encountering what? Sliding friction. Is it easy to move the body now? Yes, sir. Comparatively much more easy. But sir, Dhruv is standing in front of us. Move that idiot. Otherwise, he will again bring static friction into play. No, sir, he doesn't move. Stop. Again, static friction. Have you understood? So, man, I'm very lazy by nature. So I have moved the box. Now my box is going on sliding friction. And I keep telling the laborer beside me, Nidhi, Ivaru rose inte chala custom. We need some sort of comfort. So what comfort we can give? Hello, my muscles. See this side. This is my co-labor. And I tell every day we are pushing boxes. But physics taught us that sliding friction is better than static. I understand, but still, taklif to ho raha hai. What do? We become the airport way. Wheels laga lete hain and we walk for our flight. We convert sliding to rolling friction. Rolling friction is even more less. Wheels. If you put below your box, will it be easy for the box to move? Yes. ऐसा क्यों हो गया? अब आप खुद ही सोचो. मैंने यहाँ पे लिखा था ना, बॉडी सरफेस एरिया. यहाँ पे पूरा सरफेस एरिया कांटेक्ट में है. अगर इसी को आप व्हील बना दोगे, तो हाउ मच ऑफ द पोर्शन इज इन कांटेक्ट? Only this much. The lesser the portion in contact, the lesser is the friction. Simple. So if you want to put it in order, static is highest, sliding, then comes a rolling friction. Rolling friction. Rolling friction is least. That's the reason all these chairs and everything, you, at least, I don't know whether you consider yourself bulky or not. I'm quite bulky. I sit on my desk chair and then suddenly my wife says, oh, fan on kar do na. Do I get up? Drrr, like a CEO you go. How are you going? Rolling friction. वहीं सोचो मैं बक्से के में बैठ के कैच 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 खींच के ले जाता तो जा पाता? नहीं जा पाता, है ना? So how did the Egyptians build something called pyramids and all? If you go to engineering sites, many times you'll see in these L&T sites also, some of the big generator has come. Right now, you don't have any wheels. So they will put a lot of pipes on the floor and then offload the generator on that. Then push the generator, the pipes roll in between. एक पाइप निकल जाएगा, उसको फिर सामने लेके आगे देगा। ऐसे कर करके इजिप्ट में स्टोन्स ले जाते थे पहले जमाने में। दैट्स व्हाई पीपल से द व्हील इज वन ऑफ द मोस्ट important inventions that man has made. Achha, all of you have your kitchen trolleys. You go to your kitchen and you open your cabinet. It opens up. Do you know what are there? Ball bearings. The kitchen racks are like this. Suppose this is the closet wala portion and this is your drawer. This is your drawer and this is the rack. There will be balls like this. These are called channels with ball bearings. Suppose this your channel of your kitchen becomes bad, or these drawers, these are all got balls. That's why it comes out so smooth. See, it's not wood rubbing with wood. So there are balls inside here. यहाँ पे balls है. So it's just sliding over those balls. So sometimes when it becomes bad, you will see टक टक करके ball नीचे गिर जाता है. एक दो ball नीचे गिरा हुआ है, आपको दिखेगा. Like now it's 10-12 years old flat. 1 or 2 balls you will find, steel balls. Then it's an indication to you. After a few days, this trolley you will open like, ये रोज सुबह इसका खोलना ऐसे खुलता नहीं है, क्योंकि इसके अंदर का फ्रिक्शन मारा जा रहा है. Fans, they move so smoothly. Ball bearings. See, if you want to say suppose there is, we call this as a hub. What do we call it? Hub. A circular ring is a hub, and you have a pipe, which is in engineering we call it shaft. The pipe is supposed to rotate between the hub and not lose its diameter and center. तो हम कैसे मूव कराते हैं इसको? हम बोलते हैं हब. हब के बीच में क्या घूम रहा है बेटा? पाइप घूम रहा है. एंड हियर वी विल गिव बॉल्स. साइकिल पेडल करते हो ना, whenever you are pedaling the cycle there are ball bearings. That's why your pedaling becomes very easy. ये है ball bearing. Rolling friction. So if somebody asks you which friction is the most, sir, static friction is the most. Static friction will show its valor to you, or its power to you, its temper to you, till you are unable to move it. Once you move it, you are encountering sliding friction. Now to reduce sliding friction and bring more comfort, you added wheels. So you brought what? Rolling friction. Friction को आप बच नहीं सकते हो, होएगा ही होएगा. घटा सकते हैं. And everywhere it is opposing motion. And why does friction take place? If you look at this particular portion under a microscope, this particular portion, say if we try to look under a microscope, the top layer is not as smooth as you are looking at it, and the bottom layer is also not that smooth as you feel like. तो इन दोनों के बीच में क्या बन जाते हैं? Interlocks बन जाते हैं. Interlocks, just like the zip of your trouser. Trouser zips are all interlocks ना, ऐसे interlock होता है. तो मान लो हमारे पास व्हील कुछ नहीं है, इसको रोज मूव करना है. तो व्हाट वी विल डू? सर थोड़ा ग्रीस लगा दीजिए, ऑयल. टेक सम ऑयल. सपोज योर डोर्स, देयर आर सम डोर्स व्हिच विल ओपन लाइक हॉरर मूवीज, like that. So what is happening? The hinges are having friction. hinges के बीच में कैच पूंछ हो रहा है. तो आप क्या करते हो? अपना कुकिंग ऑयल लो ऐसे और लेके hinges, suppose this is the hinges, and you put it. So the cooking oil being very slippery will slowly guide a phase out here. ऐसे चला जाएगा अंदर. And now instead of interlock you get another interface, which is the oil interface. Top rough loves to mate with the oil surface. Bottom rough loves to mate with the oil surface. Ultimately you kill friction. Somebody like my mother, 73, 74, when they walk they have a lot of knee joint pain. So what is the knee joint? Ball and socket joint. Ball and socket joint में कैसा हो रहा है? Socket है, उसके ऊपर ball घूम रहा है. Shoulder pain. This is the ball and socket joint. I hope you know this. This bone will have a ball and the ball is rotating here. So we have something which is known as a fluid, which does not allow the bone and bone to rub. As you age, you start losing this fluid. So friction increases. Then they start complaining about knee pain, bone rubbing with bone. वो cartilage lose होना शुरू हो जाता है. समझ में आ रहा है? This is friction. So friction can be your friend and friction can be your enemy. Let us see why friction is a friend. Our friend Nidhi sitting on this stool and walking to my house is because of friction. Had there been no friction, the moment she puts her legs, sweet, she can't. We are able to write on paper because of friction. A nail is there on the wall because of friction. बटर में नेल घुसाने की कोशिश करो तो बटर में नेल टक करके गिर जाएगा. फ्रिक्शन ही नहीं है. Anything in this world is all you are able to stand, you're able to walk, you're able to grip, you're able to hold things, all because of friction. A power lifter, before lifting her weights in a championship, goes and puts some more chalk powder, gloves and all. You want to increase friction. टेनिस रैकेट में हम ग्रिप बढ़ा देते हैं, क्रिकेट बैट में ग्रिप बढ़ा देते हैं, फ्रिक्शन. These are all friction is my friend. Tires are able to grip the road, friction. When is friction my foe? Sir, my new sandal, it flattened out because of friction. Have you seen the edges of the stairs in any school? The edge will always become very, very shiny and deformed because all the children, they get down with their feet on the edge like this. Stairs में ऐसे ऐसे करके आता है ना. Look at the stairs of some old building. Their edges will never be smooth. They're worn off. Then friction makes wear and tear. Any sort of moving item, if you have, like the belts of car, brake shoes, your car brake shoes will wear out after some time. Friction causes a lot of heat. Energy loss happens. Say suppose if you want to rotate one body against another body, then there will be continuously घिसा घिसी. Heat आ गई, देखो heat आ गया. तो हीट होने से एनर्जी लॉस हो रहा है. सो फ्रिक्शन कॉजेज माय एनिमी इन दोस केसेस, फ्लैटनिंग ऑफ सोल्स, wear and tear of machine parts. So in English also we say, suppose you will find in hostels and all, suppose we two are in the same batch, you will find these stories very common in classroom. Today say me and Nidhi are very good friends in school, but we recall our grade 7 days when we used to hate, means did not even like to have the sight of one another. ऐसे होते हैं सबके साथ एक्सपीरियंस. When she first came, we didn't like her at all. Lot of friction. Today we are very friends. In order for motion to happen, today our friendship is like a motion. We are progressing. Motion होने के लिए friction होना जरूरी है. If friction is not there, motion cannot take place. Imagine the wheel that is rotating on the road and taking your vehicle ahead. It is because of friction. Take some oil and put it on your tire, and take some oil and you put it where? On the road. What will happen? The road will. On common example, braking of cars. Braking of cars. We feel that the brake helps us to stop the car. No. Brake does not help you to stop the car. You will feel, what nonsense is this guy speaking? Just imagine. Take the car and put it on jack and accelerate. The wheels rotate. When you brake up, what happens? When you apply brakes, what happens? Just the wheels get locked. The car still has a lot of momentum now. The skid and go and bang someone. That is what happens in US when it's a snowy day. Have you seen? In US, if you drive cars, then there will be one sign like this. Slippery roads. इसका मतलब है ब्रेक काम नहीं करेगा क्या सर? हाँ, ब्रेक तो काम करेगा. ब्रेक व्हील को लॉक कर लेगा. Now your body becomes a static body, but the body has momentum, na? Inertia. What happens to that? The entire body then slides and goes and bangs someone. So the car does not stop due to braking. The car stops due to the friction between the tire and the wheel. That's why when you brake, first the wheels will be locked. Then the wheels will go along the continuous road and make a dark mark. अगर वो चीज नहीं हुआ, आपकी गाड़ी नहीं रुकेगी. सो क्या मुझे अच्छा ब्रेक सिस्टम चाहिए? बिल्कुल चाहिए, लेकिन टायर्स उतने ही अच्छे होने चाहिए. अगर that's why you will find, have you seen these all-terrain bikes, mountaineering bikes? We see to go to Decathlon and all. The terrain bikes, you will see their tires are having grooves, this depth grooves. BMX biking करते हैं ना, people with their bike like tuck, and then they're able to climb. You can't do it with everything. So you need grips. That's friction. So what are the three types of friction? Static, sliding, rolling. Static is the maximum, followed by sliding, followed by rolling. Friction. So what are the things that affect friction? Friction can be affected by its weight. If you have more weight on it, it will be more difficult to move it. Roughness of the surface. More the surface is rough, more is the friction. More surface area in contact. Kirtan lying on the ground with Shishasana. Shishasana, the head is right down and the body is up. You can drag Kirtan like this, like a trolley. And me lying on the floor like an octopus. Can you drag me so easily? No, surface area is more. If the mass is more. How to remove friction? Friction can be removed by lubricating only. That's the only way we can, or by polishing surfaces. Air friction can be reduced how? By making special shapes. Have you seen the shape of a bullet train? We call it streamline. Have you heard the word streamlining? Streamlining is given to reduce fluid friction, which is also known as drag. इतना ही है friction में. And friction sometimes is also studied in conjunction with Newton's third law, that is written in going forward, so I have not touched that, but that's it. I think after this is a very numerical part that will come, turning effect of forces, and from here you get problems, angular moments, and sorry, clockwise moment, bending moments problem, principle of moments and all will come. It's friction clear. Circular motion clear. What is the facets of circular motion? Circular motion is always accelerated, speed is constant, velocity keeps on changing. Why? Because of only the direction. Centripetal force, you have understood, inward force towards the center. That's called centripetal force of friction to friction. Is there anything else on friction that I have? So in your book, they have classified friction under two heads, static and dynamic. Static friction till the body is at rest. Dynamic friction when the body is in motion. Dynamic friction further can be broken down into two types, sliding and rolling. So what should be your, if you don't want friction, all your effort should be to convert sliding friction to rolling friction. So if you're wearing sandals, please put wheels. Yeah, you do. Roller skates, when you do, what are you doing? You're putting wheels. And when you put wheels, the area of contact reduces. Are we done? So next class we go to turning moments, and that is really interesting. There you have a lot of geometry will be there and some problem doing. Turning moments, I think after that it is balancing and toppling. Then we'll win this unit. Okay. Kirtan darling, what happened?